Phase Change Unit, Lesson 3.3, Modeling Attraction. Activity 2, Explaining Attraction. Let's review your predictions from the warm-up. What do you think will happen when the two containers of magnetic marbles are shaken? In an earlier lesson, you used magnetic marbles to model how molecules behave when you transfer energy to them. In the video we're about to watch, you'll see a model just like the one you used, and also a second model where the marbles are made of much stronger magnets. Students, play the video. What did you observe about the model? What did this video show you about molecular attraction and phase change? You might say, I observed that the stronger magnets had to be shaken harder to move apart. More energy had to be transferred to the stronger magnets before their freedom of movement increased. You might also say this model shows the idea that more energy must be transferred to a substance with a higher molecular attraction in order to make it melt or evaporate. The model also shows the idea that a substance with a higher molecular attraction will condense or freeze more easily. Let's compare this model to some everyday substances. Butter and oil are different phases at room temperature. Butter is solid and oil is liquid. Which marbles in the model would represent butter and why? You might say, the stronger magnets would represent butter because they need more energy to increase their freedom of movement, and butter needs more energy to be in the liquid phase than oil. Key concept. Whether or not a phase change occurs is determined by the interaction between the kinetic energy of the molecules and the attraction pulling the molecules together. How can you connect this key concept to the video? We might say the key concept was shown in the model because the weaker magnets moved apart, or changed phase, with less energy added than the stronger magnets. Just like different types of molecules, the magnets had different attractions or amounts of attraction pulling them together. Key concept 10. The molecular attraction of a substance never changes. How can you connect this key concept to the video? The key concept was shown in the model because each type of magnet kept the same amount of attraction the whole time. Dear student chemists, I was impressed with your well-supported arguments about whether the lake evaporated or froze. I would also appreciate your help in investigating the user question on the forum about why the liquid methane lake didn't change phase earlier. Please discuss and use the modeling tool to illustrate your ideas. Then, send a screenshot along with a brief written explanation. Your explanations will help us to answer the forum user's question. Thanks, Dr. Flores. Today, you'll use the Write and Share routine to think about the Chapter 3 question. Each group member will evaluate a different piece of evidence. You will work with other group members to identify how different types have different pieces of evidence. The sim, the magnetic marbles video, and the liquid oxygen article can help you explain why the lake did not evaporate before 2007. Sharing ideas is an important and valuable way to learn from each other. Write and share routine. Carefully observe your evidence. Answer your prompt using the vocabulary cards. After everyone in your group has had a chance to write, take turns introducing your evidence and sharing your responses. While one student presents, the other should listen carefully. After each student presents, the other students in the group can ask questions or make comments. Although each group member will evaluate a different piece of evidence, you will all respond to the same prompt and use the same vocabulary words. Let's read an example description of what the strong magnets show about attraction. This explanation uses the vocabulary words each group member will use. Sample description. This video shows that even when a lot of energy is transferred in, the freedom of movement may not change. In this case, the molecules do not have enough kinetic energy to overcome the attraction holding them together. I'll give each member of your group a number. You will find the prompt that matches your number. This is the piece of evidence you will respond to. Students, respond to your prompt individually. Share your responses within your group. Once you've shared your sentences, revise your explanations if you gain new insights from your group discussion. We now have many good ideas about why we think the methane in the lake did not change phase earlier during Titan summer. Why do you think the liquid methane didn't change phase before 2007? Key concept. A phase change occurs when the kinetic energy increases enough to overcome the attraction between molecules. A phase change occurs when the kinetic energy decreases enough so the attraction between the molecules pulls them together. Different substances can have either weaker or stronger molecular attraction. End of activity.